Hello students, our next topic is relevant to the hardness. So as we told, some of the components which will be present in excess that creates a problem in the water. In order to remove that, we have to go for a suitable methods. One such component which is very common is hardness. So to some extent it is tolerable, but when it crosses some limit, but it is not at all tolerable in water. In such as cases, we have to reduce its content in the water, or else we have to go for its removal if it is for some industrial purpose. So let us understand what is hardness and how it is created in the water. As we know, most of the times, which water we say it as hard? The groundwater, whenever we will be getting it from the source of the ground, that we say it as a hard water in many areas, not in all the areas, because on all the part of the earth the quantity of the water is not similar, because whenever the rock formations are more in the soil, so when rainwater gets percolated into the source, when it goes on joining to the source of the underground water, it comes in contact with the rock formations. Because of that, some of the components such as calcium, magnesium sulfate, some chlorides gets mixed or dissolved into the water. So because of this, the hardness of the water gets increased. But whenever its limit is within like 300 mg per liter to 600 mg per liter, it is tolerable. But when it crosses its limit of 600 mg per liter, it has to be limited in the water to make it safe for the drinking. So when we talk about the hardness doesn't have much of the effects on the health, but the taste of the water will not be good, but its effects are quite different, and its effects will be most felt by the industries. Let us also check what will be the problems that is created with the hardness. When we talk about the limit, this is actually 300 is a desirable limit. When in absence of any other source, then we can go for choosing 600 as a limit. Maximum of 600 is choosable, that is permissible in the water. So what is hardness? When we talk about the hardness, we use another word called softening. So when we talk about the softening, when we are going for removal of the hardness in the water, that process we call it as a softening. So what are the problems that are created by the hardness? So problems that will be created in a house scale is the consumption of more soap. So in a household activity, consumption of more soap is one of the problem that is generated by the hard water. We can see when water is highly hard, it doesn't produce more of the lather or a foam whenever we are using the soap. This is at a house scale. Even the vessels, whatever they are using in the plumbing fixtures, there will be some scaling in the inside portions that we can see as a white spots that will be created and deposition will be created. So very common example we can take under this is whenever we are going to use a boiler unit in a house scale continuously for a hard water, we can see a white powder deposition on the coil, heating coils. That one is a problem that is developed by because of the presence of the hardness. So that is at the house scale. When we talk about the industries, so in case of the industries, it has so many problems. So because whenever in industries hard water is being used, in case of the food industries, it doesn't give a good taste. It interferes with the taste of the products that are manufactured in case of food industry. When we are talking about the cloth manufacturing, that is cotton and textile industry, it creates a dyeing activity. It interferes with the dyeing activity, and also some sorts of the spots will be created on the produced goods or cloths. So that is with the other industries. So when we talk about the other industries, so there is a problem when we are using it in, that is plumbing fixtures gets deposited with the temporary hardness, and also scaling and encrustation of the boiler tube is one of the problem. As we told, this deposition of the particles keeps going on. So someday the internal diameter what it is available in the plumbing fixtures and also the pipes which are used for carrying the water, so go on reducing. So that is a problem. And also in boiler units, it keeps on depositing. Because of that, encrustation takes place. It has to be removed further for effective, and heating capacity gets reduced as it goes on depositing. So that is the problem when we talk about the industries. That is why hardness has to be removed from the water. That is, we have to go for the process called softening. So then what are the different types of the hardness that we know? We know two types of the hardness. One is temporary hardness, another one is permanent hardness. As name itself is suggesting, this one is temporary and second one is permanent. So removing temporary hardness is pretty easy, but for removing the permanent hardness we have to go for some particular processes. So temporary hardness, why it is created in the water? It will be created because of the presence of calcium and magnesium if they are in a combination with carbonates and bicarbonates. All the combinations creates the temporary hardness, which means calcium carbonate, calcium bicarbonate, or else magnesium carbonate or magnesium bicarbonate. These combinations creates temporary hardness in the water. Removal of this is very easy when we compare it with the permanent hardness. For this we can go for a simple processes such as house scale what we are adopting, that is boiling process. It is suitable for easy removal of the temporary hardness. Another method we are going is addition of the lime. We can add lime in order to remove the temporary hardness. Next, when we talk about the permanent hardness, here also we are taking out the same calcium and magnesium, but now they will be in combination with the sulfates, nitrates and chlorides. So the combination has got differed now. If they are in a combination with carbonate and bicarbonate, it becomes temporary hardness. Now, the same calcium and magnesium, if they are in a combination with sulfates, nitrates and chlorides, we call it as permanent hardness. For example, it may be calcium sulfate, calcium nitrate, calcium chloride. Or else it may be in combination with the magnesium sulfate, magnesium nitrate or magnesium chloride. So, removal of this is pretty difficult, and we have to go for some higher version of the methods in order to remove the permanent hardness. The methods what we are picking in order to choose the removal of the permanent hardness is, first one is the lime soda method, the addition of the lime soda, and second one is zeolite method, and the last one is demineralization method. So under these methods, the zeolite and demineralization process are having the capacity to give zero hardness water, so that is completely free from the minerals. But in case of the lime soda, we can control the degree of the treatment and we can have the required amount of the hardness back in the water. So the degree of control is possible only in case of the lime soda process, but whereas zeolite and demineralization are suitable when we are using that water not for drinking but for the industries. So let us study these methods in detail now. The first method we are going to study under the removal of the temporary hardness, is the simple method of boiling, that is boiling the water. So this is a very basic method. We use it at the house scale also, but generally we do it for the purpose of disinfection, not for the removal of the hardness. But we don't know the fact that when even the boiling has a property to remove the temporary hardness also. Let us check the how the reaction goes on. So when calcium bicarbonate, that is CaHCO3 twice, is subjected to the heat, it will give rise to the generation of CaCO3, that is readily settleable, that is calcium carbonate which is readily settleable, plus it gives rise to oxide plus water. So this is the reaction which takes place when hard water which is having temporary hardness is subjected to the heat. So since this reaction is possible only in case of the calcium, because calcium carbonate is slightly soluble in water. Only when carbon dioxide is present it will be readily dissolved in the water. But whereas magnesium carbonate is fairly soluble in water, because of that the removal of the magnesium carbonate and bicarbonate by this method is not possible. We have to go for the alternate method as lime treatment. So under this reaction it is only possible for us to remove the calcium bicarbonate. Because of that, that is also one problem. And another problem is boiling can be adopted at a small scale, but it cannot be adopted at a large scale like in a water treatment plant. That is why this method is not feasible at a large scale. That is the problem. Next we are discussing about the removal of permanent hardness. The permanent hardness we also call it as non-carbonate hardness, whereas the temporary hardness we call it as carbonate hardness. In these names also the questions may be asked in the exam. So let us take out the first process. In the first process we are going to use two of the components. One is lime, another one is soda. Two of the different components. For lime, as in the previous case, we are again using the hydrated lime, that is CaOH2, and for the soda we have formula as Na2CO3. These are the two components we are going to use. So these are the set of reactions we have written here in order to understand the reaction of the hardness with the lime. So first let us check out each of the reactions. See, first of all, in all the reactions, one common component is there, that is hydrated lime. Other things we are varying, and then we are taking MgCO3. Yes, that is magnesium chloride, magnesium sulfate. This is extra, that is carbon dioxide, which is present in the water. So let us understand the reactions now. When calcium bicarbonate is present in water, when it reacts with the hydrated lime, simply the combination will work as 2CaCO3 and 2H2O, that is calcium carbonate is formed, which is readily settleable. Always calcium carbonate, whenever it is formed, it easily settles to the bottom as a precipitate. Next reaction we are considering magnesium bicarbonate. In the first reaction we took calcium bicarbonate, now magnesium bicarbonate. When magnesium bicarbonate reacts with the hydrated lime, the byproduct is simply exchanged with the ions. Combination remaining will be CaHCO3 twice and MgOH2. So here we can see CaHCO3 twice, which means when magnesium bicarbonate reacts with the hydrated lime, it gives rise to the development of calcium bicarbonate plus magnesium hydroxide MgOH2, since OH is readily settleable to the bottom. And next one we are considering is magnesium carbonate. When magnesium carbonate, and you may ask if calcium bicarbonate is left out, where the reaction is completed. Again, this left out calcium bicarbonate again undergoes with this reaction, which means it again reacts with the remaining lime in the water and gives rise to the development of CaCO3, which settles to the bottom. And next further reaction we are considering magnesium carbonate, that is MgCO3. Again it reacts with the CaOH2 and gives rise to the development of, see, we are just changing the combination. Ca joins with the CO3 and Mg go and join with the OH2. MgOH2, which is readily settleable to the bottom, and again CaCO3, which is also a precipitate and settles to the bottom. Next, these reactions we have written it for temporary hardness, that is calcium, magnesium carbonate and bicarbonate. Magnesium in combination with the non-carbonate hardness, that is chlorides and sulfates. So when we are considering magnesium chloride MgCl2, it reacts with the hydrated lime and again the combination simply changes. See there, Ca gets joined to Cl2, Mg go and join to OH2. Ultimately we want to produce MgOH2 so that it settles to the bottom. See, here we have achieved MgOH2, which settles to the bottom, and remaining is CaCl2. This is calcium chloride. Actually this is a non-carbonate hardness for calcium. It is again a permanent hardness causing agent. There is a byproduct which is left out in the reaction. Next thing we are considering is non-carbonate hardness of the magnesium, that is magnesium sulfate. Magnesium sulfate again reacts with the calcium hydroxide, that is lime, and gives rise to the development of MgOH2, similar to the previous reaction, which readily settles to the bottom, and Ca now goes in combination with the SO4, that is calcium sulfate. See, calcium sulfate is again a non-carbonate hardness of the calcium. So then further reaction is the dissolved form of the carbon dioxide present in the water reacts with the lime and gives rise to the development of CaCO3, which settles, and then H2O is left, that is water is left. Only problem that is left out for us is removal of this non-carbonate hardness of the calcium, that is nothing but permanent hardness that is created because of this calcium chloride and calcium sulfate. In order to remove this, we are going to make use of the another component what we have taken, that is soda, that is Na2CO3. We are going to make use of that soda and we are trying to remove these two components in the water. As we got from the previous reactions, the byproducts left out were the non-carbonate hardness of the calcium, that is calcium chloride and calcium sulfate were left out in the reactions when we took up the reactions with the hydrated lime. So in order to remove these components, we are going to make use of this that is soda. Then it can also be removed in the water. So if we are going to not remove these products, again water will not become hardness free. So in order to remove this permanent hardness which is created by these two byproducts, we have to make the reactions possible. So again both of the products reacts with the Na2CO3 and gives rise to the byproducts which are set level. That is Ca goes in combination with CO3, that is CaCO3, which settles to the bottom, and left out is 2Na and 2Cl. So 2NaCl, sodium chloride. Okay, and then when we consider calcium sulfate which reacts with the Na2CO3, again the combination will be very simple. Ca go and join with CO3 and remaining is Na2SO4. CaCO3 which settles to the bottom and the remaining is Na2SO4. So these are the reactions that takes place by making use of the soda that we are using it in the process for removal of the permanent hardness that is created because of the calcium. After learning the lime soda process for removal of permanent hardness, let us discuss its advantages and disadvantages. Under the advantages, we can say this process when we compare with other methods for removal of the hardness, which is very much economical, since we are going to use only two of the components, that is lime and soda. That is two can be added in any other unit. Special structure for it is not required. Because of that, it proves to be economical, and also it can be easily combined with the other treatment processes what we are going to use it in a treatment plant, which means in a regular tanks what we are going to use it for the treatment, in the same tanks we can go for treatment of the hardness also. We can combine two of the processes. And also coagulation process and softening process, when they are combined together, as we told with the combination, lesser quantity of the coagulant is required because it increases the pH of the water. Addition of lime and soda increases the pH of the water. Increased pH always supports the coagulation. That is why lesser quantity of the coagulant is required when process is combined. And also it increases the pH because lime and soda both always increases the pH. Because of that, it reduces the corrosion problem. Whenever water becomes acidic, there is a problem of the corrosion in the distribution system. That is why because of the increased pH, problem of the corrosion is reduced. Next, increased causticity, nothing but the addition of the soda. Because of the addition of the soda, the increased causticity, some of the pathogenic bacteria cannot survive in that kind of atmosphere. Because of that, some of the pathogenic bacteria kills here itself before we go for a disinfection method. That is the advantage. And next is the total mineral content of the water, which means along with the minerals that cause the hardness, other minerals also gets reduced in the water, which is a byproduct or a helpful thing for us in removal of the minerals which are unwanted in the water. Lastly, it helps in removing of iron and manganese also along with the removal of the hardness. And next we shall discuss about its disadvantages. In all the reactions we told that some product comes out as a byproduct which readily settles to the bottom. That product which settles to the bottom, we call it as a sludge. Large amount of the sludge is produced here because every time we told as a product of the reaction some settleable product is coming. That is, increased sludge production is a big problem, and again disposal of that is a problem in case of these methods. And whenever we go for this method, we are going to add a chemicals. That is why careful operation and skilled supervision and also a labor is required for addition of the chemicals properly into the water. Next, it doesn't helps us to produce zero hardness water. Some amount of the hardness is left out after this process also. Zero hardness is not required for the drinking purpose, but for some industries zero hardness water is required. So, and lastly, encrustation of the pipe walls in distribution takes place because we told that powder, that is CaCO3, starts settling to the walls of the pipes that will be present in the distribution system. Because of that, encrustation, hardening of the pipe material starts. That is a big problem in case or disadvantage with respect to the lime soda process. These are some of the advantages and disadvantages with the lime soda process. Under the next process for the permanent hardness removal, we are considering zeolite process, which is also known as base exchange process or cation exchange process. So under this we are considering a material which is a zeolite. That is, zeolite is a natural salt or a clay which is actually a hydrated silicates of sodium and aluminium. So if they are available naturally also, or else they can be manufactured also. When they are manufactured, we call the manufactured zeolite as resins. So this is a natural condition. If it is present in a as a natural salt or a clay. So hydrated silicates of sodium and aluminium. So Na2O3, Na2O, Al2O3X, SiO2Y, H2O. This is a general formula. X and Y are used here in order to indicate the combination. These combinations may keep on changing. So this is the formula. We use it for understanding the hydrated silicates of sodium and aluminium. This natural zeolite has a property of getting exchanged its cation with the other product. So because of this property we call it as cation exchange process. So whenever it is artificially manufactured also, it is possible to get the same combination, and also this entire reaction takes place in some closed vessel. That process we are going to understand further how it is taking place. A bed of this zeolite is formed in a pressure vessel and water is passed through that bed, just like we do it in a pressure filter, and because of that easily the softening is achieved. Let us check what kind of the reactions that takes place when we considering the base exchange or zeolite process. When I am considering sodium zeolite, that is sodium zeolite. So when we consider this in combination with the calcium and magnesium, either they may be bicarbonate, sulfates or chlorides. Simply the cation, that is sodium, gets exchanged with the calcium and magnesium, with the, that is cation of both the components gets exchanged. That is why we call it as a cation exchange process or a base exchange process. Here we can see the cation now instead of Ca and Mg, it has got replaced with the sodium. When sodium is in combination with these components, it doesn't create the hardness. So our intention is achieved here. And then zeolite go in combination with Ca and Mg. So when bed of this gets saturated, in order to regenerate the zeolite, because zeolite is a costly material when we are going to manufacture it, in order to get to regenerate it back when we are using it, we have to use 5 to 10% sodium chloride solution, which we also call it as brine solution, BRINE, brine solution. If we are going for backwashing the bed with this solution, again we can generate the zeolite back, because we are going to give sodium, again cation gets exchanged with the calcium and magnesium, and water which is coming out after the washing contains the calcium and magnesium, but sodium again goes to its place, and sodium zeolite will be again ready for the process. The zeolite softeners what we use, either they may be of a gravity type or the pressure filters, and the most common which is used being the pressure filter as shown in the figure, and the rate of filtration through a zeolite softener is around 300 liters per meter square area, that is per minute, and the process here results in a zero hardness water. If we want to control the degree of the hardness, we can mix the water which is of a zero minerals with the hard water to achieve the degree of the hardness what we require, because zero mineral water is not suitable for the drinking purpose, but it can be used for the industrial purpose. And here in the figure we can just check the arrangements. This entire container, we say it as a pressure vessel. Under this we have a zeolite bed. This crossed portion what we are seeing is a zeolite bed or a cation exchange resin. And then let us check the other arrangements. Here are the troughs we can see. These are a set of troughs which are used for collection of the water. That is why we have mentioned here this is a water collecting system. And lastly, entire system is supported on a base concrete. It has a stand also. And then the inlet for the hard water is being located here. So this is a valve operation which is present, that is inlet. Hard water enters through this head water distributor which is shown here. So from this the water gets entered, and after the filtered water is coming out in the water collecting system, it will be taken out from this wall, that is filtered water outlet. This is during the regular operation. And the other arrangements are also present in this. Let us check that. This is a container which is having a solution, that is sodium chloride solution, 5 to 10% sodium chloride solution that is used, which we also call it as brine solution, which is required for regeneration of the zeolite. Regeneration means once all the cation in the zeolite bed get exchanged with the calcium and magnesium, there is no further zeolite for continuing the process. So in order to make it again reusable, we can go for brine water distribution, so that again the sodium which was present earlier gets replaced in the zeolite bed, just like we do it in the backwashing of the rapid sand filters. Otherwise the sand gets clogged out. In that case, here in order to regenerate the zeolite we use this process. And here we can see this is a tank which is containing the brine solution. And then from here, during the regeneration process, through the operation of the hydraulic injector, brine is distributed into the system, which again makes us the zeolite bed to be used again. And the hard water which enters through the tub is evenly distributed through the entire zeolite bed, and the softened water is collected through the strainers at the base. And when a significant portion of the sodium in the zeolite has been replaced by calcium and magnesium, it is regenerated first by washing it with the water reversing flow and then treating it with the 10% solution of the brine solution. In order to go with the just water washing, we can just open this valve which is present here and send the water here. After doing that process, we can just send the 5 to 10% of the brine solution, and the excess brine solution retained in zeolite after the treatment is removed again by washing it with the good water. This is the process for understanding the zeolite process. After learning how the process of, that is the zeolite process, is taking place in a closed vessel, next let us understand its advantages and disadvantages. When we take up the advantages, so the best reaction or the byproduct what we can get here is the zero hardness water, which is the best suited for the industrial use but not for the drinking purpose. When that can be said under the disadvantage that whenever we want the water to be use it for the drinking water, this is not at all suitable, zero hardness water. So only it will be of best use in case of the industries. And the unit, as we saw in the explanation of the process, unit is very compact, that is a smaller unit, and also it is automatic since it is a pressurized vessel and very easy to operate and maintain. So that is the advantage. And next, here in this case, there is no formation of CaCO3 or MgOH2. No such sludge deposition is taking place here. Because of that, disposal of the sludge, all those problems doesn't exist with respect to the sludge. And RMO cost, which means the running cost, maintenance cost, and also the operation cost is very less when we compare with the other method. Here it also helps us in removing iron and manganese along with the removal of the hardness. And here there is no difficulty whenever we are choosing the water with varying quality, which means the water which may have any other mineral contents which are high. So even in such a case we can go for this process, since it has a property of making it zero mineral water. So, and the last is, it doesn't have a problem of incrustation because there is no formation of calcium carbonate or magnesium hydroxide, all such products here. Because of that, no byproducts which is there which gets settled to the walls of the pipe. That is why there is no problem of the encrustation. But along with having these disadvantages, it has some of the along with these advantages, it has some disadvantages also. Let us check its disadvantages. It is not suitable whenever water is highly turbid. Turbidity is a visible pollution. When somewhat we can consider, for example, water is so much muddy. So when this kind of water is made to enter through the pressure vessel, the pores gets blocked easily. So in the bed. So because of that, we cannot treat water whenever it is highly turbid. So that is one problem. And second one, as a product of the reaction, sodium bicarbonate is formed. Sodium bicarbonate creates the problem of foaming in case whenever it is used in the industries. So foaming is not at all desirable whenever it is used for the industries. For examples, in some of the industries we may be using the water for cooling purpose. If the cooling water itself is producing the foam, the removal of that foam and maintenance of that water is very difficult. And lastly, this process proves to be costly and unsuitable whenever iron and manganese is present in the water. Mn, iron and manganese is present in the water. So because iron and manganese, just like the base exchange takes place with the hardness, here these also gets exchanged with the zeolite, that is sodium gets exchanged, cation gets exchanged. So when such a exchange takes place, regeneration of the zeolite is not at all possible in this case. That is why this is not suitable and it is very costly, because regeneration is not possible. Every time we have to use a new zeolite in order to remove the product. That is why when iron and manganese are more in the water, this method is not suitable. These are some of the advantages and disadvantages with the zeolite process. Next, let us check the comparison of the lime soda process and the zeolite process. When we take out the items, that is, first one is the size of the plant. As we told, lime soda process requires a large tank. Because of that, we say it as bulky and large. But as well, when we compare the zeolite process, a small pressure vessel is used. Because of that, it proves to be compact and small. This is the first case when we compare the size of the plant. And next when we check the skilled supervision, there is a necessity for obtaining a good results. And in the second case, automatic and easy to operate. In the second case, it requires a skilled supervision, because in order to get a good results. But in the second case, entire system operates automatic, since it is a pressure vessel, water is sent under a pressure and easy to operate. And when we compare sludge trouble, large quantity of the sludge is settled and formed in case of the lime soda process, because in every reaction we can see some settleable product, but no such byproduct is coming in the zeolite process. Because of that, there is no problem of the sludge formation. Because of that, sludge disposal is also not a problem in the zeolite process. Next, when we compare the post treatment, that is after treating with the hardness removal process, what are the process or treatment we need to give after that. So when we compare, recarbonation is a must after sedimentation filtration, otherwise encrustation of the pipes will occur. As we told, it gives rise to the generation of CaCO3, which creates a problem of encrustation. Because of that, the removal of that is a main intention here. In the second case, no such post treatment is required. Already it produces a zero mineral water. Because of that, no further treatments is required. When we compare the results obtained, this can produce, that is, lime soda can produce water of hardness not less than about 50 mg per liter, and therefore useful for public supplies, that is drinking water. But in the second case, water of zero hardness can be obtained, which is therefore useful only for the industrial supplies. Next, when we talk about iron and manganese removal, color due to iron and manganese can be removed to a small extent, but when we talk about zeolite, can remove efficiently but treatment becomes costlier. As we told, iron and manganese, when they get exchanged with the cation of the zeolite, process is irreversible. That is a main problem. And when we check the effects on the bacteria, due to the increased pH by the use of lime and soda, the process increases the pH of the water, thereby killing the pathogenic bacteria. That is, increased pH is not suitable for the bacterial survival. But in the second case, no such advantage, because there is no variation of the pH due to the reaction with the zeolite. And next thing we are discussing is the pH of the treated water. Next item, that is pH of the treated water. The increases the pH value of the water, which reduces the corrosion of the distribution network when water is sufficiently acidic. So in such a case, we can increase the pH value, and increased pH always reduces the problem of the corrosion. But no such advantage is achieved in case of the zeolite process. Then when we talk about the economy, the lime soda process is economical and can be easily combined with the other usual water treatment methods, but slight extra cost is required in order to install this process in addition. But zeolite process is costlier, since we can check the regeneration has to be done, and the process installation needs a pressure vessel and also a bed of the zeolite resin. All such things are needed. Because of that, the process proves to be costlier. And next item, when we take out hardness, which can be treated. Excessively hard waters, particularly those which are high in magnesium hardness, can be treated by lime soda process. And when the raw waters with hardness greater than 800 mg per liter cannot be easily and economically treated. These are the comparisons that are stating us how much hardness water can be treated under these two methods. Last one is allowable turbidities. Highly turbid and acidic water can also be treated, because here we are not at all using any kind of a bed, simply we are adding the chemicals. And also, even though water is acidic, by addition of the lime and soda, pH can be balanced. But in the second case, highly turbid waters are difficult to treat, as they may cause choking of the zeolite bed. That is, the bed gets clogged with the turbidities, or the particles which will be present because of the turbidity. So because of that, turbid water are not suitable for zeolite process. This is about the comparison of both the methods.